I hope you're ready for another action-packed selection bias graphical example with full explanation, because that's what we're doing. Okay, so this is going to be a complicated one, so bear with me. So once again, I have some sort of treatment value A. This treatment value A is going to be some sort of retroviral therapy. The retroviral therapy is painful. People don't like it. It's going to affect the chance that they drop out of the study, either through death or through just leaving the study itself. I'm going to say that this effect of dropping out of the study is also going to be caused by, for example, and I'll use the same color in this case, this effect of dropping out of the study is also going to be caused by symptoms. So symptoms that they might be getting from, in this case, I'm going to assume that this is an HIV study. This symptoms is going to be caused by the resulting just immunosuppression that has happened. Let me go ahead and put the U in a different location. It's going to be helpful later on. So these symptoms are going to be caused by immunosuppression that has happened as a result of HIV. And this immunosuppression will affect the outcome that we are interested in, and that is 3-year survival rate. Okay, so we've got a complicated diagram. Question: is there selection bias? So once again, the best way to do this, I think, is just to go ahead and write this out in one line. So we have some sort of A, which affects some sort of value of C, which in this case is likelihood to drop out. The likelihood to drop out is actually affected by a value L, which are the symptoms. L, which are the symptoms, are going to be affected by the underlying immunodeficiency. And the underlying immunodeficiency is going to be affected, or is going to also affect the outcome. The outcome in this case being the 3-year survival rate. So question: is there an effect? Well, we go ahead, we go along the chain. This chain is fine, this chain is fine, this chain is fine. Blocker. We have a blocker, which is C. However, we're conditioning upon C, which is whether the patient dropped out of the study or not, because we can only survey people that didn't drop out of the study. So we go ahead and we say, yes, there is an association between A and Y. Now, as I discussed before, one of the best ways to control, or one of the ways we can control for selection bias is assume exchangeability of patients that dropped out. So in this case, if we assume the patients that dropped out are of similar condition to those that did not drop out, then we can go ahead and we can actually compute the average causal effect in the total population. But let's not make that assumption here. What else could we do? Well, if we actually went ahead and we did one more thing here, we conditioned upon these measured symptom values, L, so it's measured, we can go ahead and we can say that, hey, A is actually blocked by L, so there's no association between A and Y when there's no causal effect. Voila, we have exchangeability again. Okay, hopefully that was fun. Let's do another one right after.